let's discuss the practical household electrical power systems that we have and the different safety devices such as fuses and circuit breakers and the ground plug in these systems that we use. So first, let's review. Remember, direct current is used in things like a flashlight being powered by a battery, or any automobile will use a DC system for all the electrical devices within the automobile. But nearly all households and commercial and industrial systems will use alternating current. And so what we have over here, this diagram below here, shows you a household circuit within a house. So you have the electrical power company providing some power coming in, and you have this red line, typically called the hot line by electricians, and this blue line here, which is called the neutral line. And this is the electrical meter as it comes in, and you should be reading these you could see the kilowatt hours if you were to look at your electrical meter here. That main line that's coming in here has a fuse, and we'll talk about a fuse in a moment. And then you'll see that all these outlets here and all the devices that are connected via these outlets are all connected in parallel. Now we'll talk about what a parallel circuit looks like and how what that is in comparison to a series circuit a little later on. But in your typical household, you may have up to something like 4 to all the way up to possibly 30 different branches. In this picture, we only have 2 branches, so you have maybe one room with these 3 outlets and another room with these 3 outlets. But your household may have a lot more branches, obviously. These outlets, well, in Singapore, they look like this, typically. You have 3 little holes here. Now, this top square hole right here is called the ground, and these 2 lines, the one is called the hot and this one is called the neutral. And now the neutral over here is connected to also, if you can see here, there's that neutral line here is connected to the ground. And so for houses, the ground is actually an electrode that is typically driven right into the earth, usually something that is a good conductor. And there are times, maybe in older households, they might connect the ground to a cold water pipe. Electricians speak of hot side and neutral side. Most modern house wiring systems have 2 hot lines with opposite polarities, so that you have one going, so that you could achieve, for example, a 240 volts if you wish in the United States. So you'll notice that some of the bigger appliances in a typical American home will operate at 240 volts because you may have a 120 volt line and another 120 volt line that are in opposite polarities. Okay, so now so you should understand, why do we have this ground wire that is connected to the ground? If you look at this this device here, this is just simply a 2-prong plug being plugged to this wash machine, or it actually looks like a dryer. And there's a heater in here, this resistance, and as the current flows through here, it goes through this circuit, and here it goes through along in here, and this is your alternating source of power. However, say this person came along and touched the surface, and for some reason this dryer were to malfunction, somehow that this wire disconnected from the rest of the circuit and started to touch the outside surface here, which is a good conductor, and that person was touching that surface, and that current will take the path of least resistance, which happens to be through that person's body, and as they go right down to the ground, then you've got that current going through that person's body. Obviously, that's not a good thing. So how do we prevent that sort of thing to happen? Well, we need to connect something to this particular device to prevent that leakage of current going through that person's body. So therefore, we have to have something, a 3rd wire that will connect along through the outside surface of that device that goes through that prong. Here's your ground plug that would then connect through here, and then that would then connect all the way down to the ground. And so that's the purpose of a ground plug. So obviously using a 3-prong plug versus a 2-prong plug is a lot safer. Now you also have within households something here called a fuse. Now, a fuse is needed in household because if in your household, your wires will start to melt if you have too high of a current going through them. And therefore, we have to put a device called a fuse within your circuits to prevent that overheating of the wires, which could lead into an electrical fire. So, what is a fuse? Now, here's a picture of a fuse over here. A fuse basically contains, if you look closely in here, a little lead tin alloy with a very low melting temperature. This link will melt and break the circuit when its rated current is exceeded. So if this was for example, a 5 amp fuse, and you were to go above 5 amps, and this little wire would break and no longer current would go through this section, and so suddenly all these electrical outlets would go out. So that is one type of device that you can use within the household. Another type of device that we have is called a circuit breaker, which is I've just shown now by deleting the other picture. A circuit breaker is basically an electromagnetic mechanical device that performs the same function but uses an electromagnet or a bimetallic strip to trip the wire, as we call it, or trip the breaker, and interrupt the circuit when the current exceeds a specific value. This is more common nowadays. So you have these little switches. You may have seen this box within your household, and so when the current is exceeded within that circuit, this little switch flips over to the side, and it's been, as we call it, tripped. And that's because the current has been exceeded within that particular branch of the circuit. And so you can flip it back if the current, once you've found out what device is basically shorting out your circuit. Okay, and to go back to this fuse, as I should have mentioned as well, it's obviously very important that you don't replace a fuse with another fuse that is of a higher amperage. So for example, if this device had a fuse of 5 amps, you're not going to go and replace it with a 6 amp fuse, because now you could be operating your device at a higher current than it was made for. Okay, just to recap, in house wiring, one line that enters the house is always neutral, or at the same voltage as the ground to which it is connected. The other line, or one or two lines, are called the hot lines. The maximum current available from individual circuits is limited by the resistance of the wires, and so you do not want to carry too much current, which could cause heat loss through the wire, cause them to melt, and then possibly cause an electrical fire. So protection against these overloading of circuits is provided by fuses and circuit breakers, and also then protection against a human possibly getting electrocuted is that third prong called the ground prong, so that if any electrical charge that starts to leak out to the surface is going to not go through that person, but it'll go back straight to the ground. And so that's it about safety in households.